Welcome to the latest webinar sponsored by the Workflow 4.0 e-newsletter and ClearEdge 3D. Our webinar topic today is new tools and workflows to scan and model as-built ducting and other MEP systems. Hi, my name is Kevin Corbley and I'll be your moderator today. I'm the editor-in-chief of Workflow 4.0, the newsletter of 3D scanning, modeling, documentation, ideas, and opinions. First, let me start by thanking you, our attendees, for joining us today. Modeling as-built ducts is one of the most challenging aspects of MEP work. Ducts are typically non-standard sizes and they're full of difficult transitions, and Revit just doesn't have the tools to model ducts accurately and easily. We know duct modeling must be a popular topic today because this is one of our biggest webinars to date. Close to 500 people have registered, and we know you'll be pleased with what you learn in the next hour. Let's take a quick look at our agenda. We have two professionals from the scanning and modeling industry who will be relating their experiences with ducts and MEP features in recent BIM projects. First, Chris Heliotis will be discussing an as-built duct model at a large medical center, and then we'll hear from Mark Hanna, who created an as-built BIM for a sports arena that will be very familiar to many of you college basketball fans out there. And then Kevin Williams will join us to give a demo of the new duct modeling tools in the Edgewise BIM suite. And as always, we'll wrap up by letting you in the audience send in your questions to our panel of experts. Let's quickly run through our housekeeping details. Everyone in the audience will be muted during the session, and feel free to send questions in via the question box at any time during the session. But we'll be taking questions at the end during the Q&A session. This webinar is being recorded, and you'll each receive a link afterwards letting you know if you want to send it along to somebody else or if you'd like to watch again. And don't forget to subscribe to Workflow 4.0. That's the e-newsletter for learning, and it tells you about sharing experiences, opinions, and best practices. And let me make a few quick introductions here. First up is going to be Chris Heliotis. He's the project manager with Westlake Consultants, and he has more than 10 years of experience in scanning. And Chris has a background in meteorology and geomatics. Interesting combination there. Another familiar face, somebody who's familiar to many of you, Mark Hanna. He's been with us before. He's the president of Precision Point in Carmel, Indiana. He founded Precision Point in 2009, and his educational background includes mechanical engineering and surveying. And many of you already know Kevin Williams. He's the chief scientist for ClearEdge 3D, who founded the company back in 2007. Gentlemen, we're happy as always to have you. And let's take a quick look at what you're going to learn today. There's really a lot we're going to tell you, but here are the key takeaways. First, you're going to learn about two very large, very complex BIM projects that Westlake and Precision Point tackled while keeping their client satisfaction and their own bottom lines in mind. Chris and Mark will show us how they integrate the latest tools into their deliverables, and you'll also find out how to speed up the as-built BIM workflow with duct modeling tools. And you'll have a demo showing how easy it is to use the duct modeling tools and other features in the October release of Edgewise BIM Suite. Okay, and now that we are done with our housekeeping and intros, I would like to bring on Chris Heliotis, and Chris is also going to be joined by Jerry Dawson, who's Westlake's senior scanning technician. And let me give the controls over to Chris.
All right, I've got it. All right, well, good morning. First off, I'd like to thank Chris and Kevin for involving us in this morning. I guess first a little background about Westlake. We're located in Portland, Oregon. Been around since 1983. We hover around 50 employees. We've been scanning since 2003 when Westlake purchased their first Syra. We are a civil firm sort of split into three divisions. We've got our civil engineering, we've got our development survey, which is, I guess, more your traditional land surveying, and then we've got our industrial measurement division, which includes high tolerance surveying as well as 3D laser scanning. The project that I'm going to talk about today was a regional medical center. We did 3D scanning and modeling for about 30,000 square feet, which included 3 floors of the facility, and it was in the operating patient wing. The areas to be scanned included the primary travel corridors outside the patient rooms, the nursing stations, and then the interstitial located above those points. The point, I guess, of the scanning was as-built mapping for existing conditions to do a design of MEP in place so that they were able to design and replace without ever interrupting operation of the facility. And what we were handing off to the client after scanning and modeling would have been a recap cloud, a Revit model for clash detection, and a Navisworks model. The scanning itself, it was 3 mobilizations, about 6 man days, and modeling took about 3 weeks in addition to that. Let's see. Okay, some of the challenges. Done a few of these hospital projects now, and they're all kind of unique. In the past, we've worked in cordoned off areas, which was a little different. We've had to work from containments, which offers another challenge altogether. This was different in that this was an operating facility that could not be interrupted. We did not have to use a containment in this case, but we were only allowed to remove 1 tile at a time. So we had to obviously take great care not to interfere with the staff, not disturb the patients. If we were told to move, we moved. We tried to operate around meal schedules and other things where we'd be interfering with the corridor itself. And capturing the data was difficult, as anybody who scanned above ceiling tiles knows from experience. We took a little bit different approach where we actually registered this data targetlessly, which was the first time I'd attempted it, and it actually worked to great effect. Cut down a lot on the targeting time. So as far as collecting the data, we used 2 scanners, Ferrofocus F120 and X330, both mounted on 10-foot extendable tripods. The situation was, if we didn't want to use containment, we could only remove 1 tile at a time. So the workflow itself had to be customized to that end. So what we did initially is we went around and we scanned the corridors themselves as a baseline for our registration. Then we'd remove a tile. We'd hike the scanner up into, I guess you'd call it the breach, between the ceiling, the subceiling and the floor below, and we'd do a scan to capture data above and below so we had commonality, and then we'd do another scan up in the interstitial. So I think I'm going to hand it off to Jerry to talk about the workflow a little bit, as I don't want to spew any misinformation since he's been doing most of the hands-on work. So Jerry, why don't you take it?
All right, do I have access? There we go. So once we got the scan data back from the field, we would take it into the recap software, where we would register the scans like Chris said, targetlessly, and then once we're done registering the scans together as a large cloud, we then would rotate the data to base drawing, and we use Cyclone for that. And from there, we have been using the edgewise piping extraction, so we would kind of divide the project up between a couple different modelers, and we would use the EFT7 format and bring it into edgewise, and then one person would start doing piping. Well, for the duct work, a little more labor intensive. We were using Cyclone a little bit. Then we moved into Rhino. The problem there is there's no easy button. You basically had to make an access line down a ductwork or make a curve extrusion, and then you would have to try to balance it and move it through the cloud, which many times was difficult because from the angle we're shooting these scans at, you only see usually the bottom, and if you're fortunate, one side, and rarely more than two sides. So most of the software we're using, there's no intuitive way to extract the ductwork. It was all make planes, connect them, extrude boxes, and it was very time consuming, and elbows were even more excruciatingly painful to make. So when we had a chance here to use the edgewise ducting tools, it really a noticeable difference right away. One of the things we had to do with our old way was take the data from like recap, shrink it down, and then import it into the software. You couldn't bring a full cloud in, otherwise the software would just would choke on it. Well, here you have the edgewise. You could bring the whole cloud in, all 3 floors, 3,000 square feet, and it still works. It's very, very fluid. Then you just use the clipping box. It was a great tool to isolate a section of the ductwork that I wanted to start with, and I noticed that you needed more and more isolation. If you got too much depth, where there's too many things underneath, it had a little harder time making an initial placement. Do I have access to the next slide, or Chris, do you still have that? There we go. Thank you. I want to go to the next slide, Chris. Is you can reuse that size, and you can set that as your standard, and then you can go through the rest of your straight ductwork, and instead of it trying to resize to the duct, it would just use the size you just chose and then just do a best fit to the cloud. And that was amazingly faster than trying to, for each piece of duct, like I say in Rhino, recreate it from scratch or try to realign it from scratch. The snapping tools were a real big help. A lot of the problem was running to before was having the ductwork stay collinear. So when you go to do an elbow, it actually makes an elbow that is, parallel to the floor or to the ceiling. And the elbows, I noticed, were a lot quicker to do here in this sorry, I can't think of the program now. Edgewise, sorry. Normally, when you make an elbow, in most software we use, as soon as you adjust that elbow, it breaks connection. You got to reconnect it to the ductwork. The elbows and the edgewise were great because once you've made the connection, you can use those grips, the red arrows, that blue grip there, and you can adjust the length and its placement, and it keeps it collinear to the ductwork on either side. So elbows were a real time consumer in every other program we used. This really helped. The transitions were the same way. There was no issue with the transitions. It can do some really strange size adjustments and turns, and as you'll see in the demo coming up, it went one to the other perfectly. Next slide, please. And the smart sheet was another time saver. In our old workflows, there was no real way to track what duct we have used, and you would have to click on it, see what the size was. The smart sheet, once that activated, it keeps almost like a spreadsheet of what you've been using, and if you need to make adjustments, you can actually make adjustments on that spreadsheet and have it make the adjustment right there in the model. And then if you look at the left-hand picture, the black box there, that's looking down the axis of the ductwork, and so you can align and get your ductwork right where it needs to be, even if you only have maybe only two sides, and that was a real time saver. The integration with Revit is great. You just use the export tool, and it comes in as a Revit object. And whereas our old workflow, you took a chance that when you brought it in that it would explode itself, and of course you would have multiple planes and lines and have to rebuild the thing. So the Revit integration is great. So the total duct modeling tool, just in the short time we've used it, it really has at least doubled our production rate and accuracy. And if we can get the sizing list pre-hand to our modeling, we can even just plug that in and have it just automatically make ducts only the size that we're going to use. So that right there also is a time saver. The only couple things that I would love to see added is copying. Many times, like in the medical facility, there's these bay bump outs, and the way the ducting goes into them, they are identical. And when you got 30 of those bays, it'd be really nice to create one complete bay and copy the whole ductwork of that bay and move over to the next one. The set button works great for individual duct, but if we maybe grab multiples and move them all at once, would be great. And then the clipping box works really well. The only thing is if you go to reset the clipping box to an axis, the x-axis of a duct run, it automatically runs to the extent of the whole project, which means then you've got to resize it again. But other than that, these tools are fabulous, and I'm very happy to continue using this product. So that's the basic workflow, and I'll turn it back over to Chris.
All right, thanks, Jerry. Okay, so ultimately, the deliverable that was needed by the client was sort of twofold. They had not dealt with point clouds before, so they had come up with preliminary design, I guess, in 3D based on 2D drawings, and we provided a point cloud for them to use within Navisworks to do a clash detection against their preliminary design. Took a lot of coaching. Like I said, it was their first foray, but once everything got running, it was great. And then they were actually doing their design work within Revit, so we kind of helped smooth the process there of utilizing the point cloud within Revit itself, in addition to being able to use the extracted piping and ducting. The toughest part really was just kind of helping them get their head wrapped around what to do with a point cloud, which tends to be the case. And as far as lessons learned over several of these processes or these projects, I've found that planning and communication at the start of the project are huge, especially when you're dealing with clients who are not familiar with dealing with point cloud data. Spend the time to get a very clear picture of what their problem is and come up with a solution to help them solve that problem. A lot of times they don't know enough about the information, about the data, to really tell you what they need until you can coach them once you understand where they're trying to get. And make sure they're crystal clear regarding what they're going to receive. A lot of these guys, their only exposure has been these beautiful presentations by the manufacturers of the scanners and the software, and so the expectation is going to be this beautiful BIM model, fully intelligent, push a button and it out pops from the point cloud data, when those of us in the industry know that's not the case. And make sure you're not over-promising, and make sure they understand that there are some limitations. Another thing, don't skimp on scans. I've never saved time or budget by shorting it in the field, because in the end it ends up screwing you on the back end in the office, and it ends up costing you double at that end. So don't skimp on scans. If in doubt, scan more. Also, develop an efficient workflow between various software platforms. We're moving in and out of various point cloud processing programs, modeling programs, Edgewise, Rhino, AutoCAD, cyclone, recap, develop workflows. Each one of those tools has benefits and does something better than the others, but if you can't move in and out of them smoothly, you're going to struggle. Make yourself available through the life of the project and try to budget accordingly. When you're dealing with people that haven't used the data very much, you're going to spend a lot of time on the phone or at their office getting them up to speed. We don't want to sour them on the technology because it was too difficult for them to work with ultimately. I think that's about all I have.
Okay, great, Chris and Jerry. Thanks a lot. Actually, before you guys mute yourselves and before I go over to Mark Hanna, we did have a quick question come in. I think I'll throw it at you now. Somebody wanted to know if you lost any elbows when you took the model over into Revit.
I didn't know. I didn't see any that were lost.
Okay, well, I guess that was pretty easy.
No.
Pretty straightforward. Okay, all right.
I've seen it with piping before. I didn't experience it with the ducting at all.
Okay, all right, very good. Well, gentlemen, thank you, and we're going to have you back in a few minutes. But for now, I'm going to hand over the webinar to Mark Hanna, and he's going to peek inside the house that Bobby Knight built. Mark, it's all yours. You've got the controls.
Thank you, Kevin. I appreciate that introduction. And yes, as Kevin indicated, we have the fortune to work on a really exciting project here in the Midwest. For any of you college basketball fans, especially these here in my home state of Indiana, beloved Hoosier fans here. So we'll get into that in a second. But before we do, I'd like to share a little bit about who we are. And there we go. Sorry, a little delay there on the slide. So we're Precision Point. The company was, we're kind of unique. We built the company specifically around 3D scanning solutions and scan-to-BIM modeling workflows. Since our inception in 2009, we've completed over 200 projects. Myself and my staff all come with backgrounds in surveying, mechanical, and civil engineering. And we pride ourselves on providing engineering design-grade point clouds. We mainly work in the AEC and industrial factory industries. We uniquely train our in-house modelers who are Autodesk certified, and we're really specialists at converting point clouds into BIM models. We do offer these services nationwide. We also offer our modeling services out to third-party partners as well. So we work with lots of people in the industry nationally. Not only are we avid users of Edgewise, we're also very proud to be resellers of the product as well. And I think that's just a testament to how much we believe and what this product and what the team over at Clear are developing. So yeah, we had a really unique opportunity, and as you may or may not know, here in Indiana, basketball is king, and the home to the beloved NCAA men's IU basketball team is Assembly Hall. It was, as Kevin indicated, the house that Bobby Knight built in 1971. In fact, it was the first year he started coaching there, so that's pretty significant. But after 42 years, the arena was starting to show its age. So a $40 million modernization project was started this year from a donation, a very, very generous donation. The modernization would include a new south lobby, a grand entrance to the arena, which doesn't exist today, the addition of luxury box seats, concession and bathroom updates, a new scoreboard, and behind the scenes HVAC and other critical MEP infrastructure was going to be upgraded as well. We were brought into the fold because existing record drawings were poor and mostly outdated, and So there wasn't a lot of confidence in moving ahead, and since the design was going to be completed in Revit, a starting point for generating a Revit model for the entire facility would have been was a perfect starting point for both the designers and the university. Now, although some of the improvements were just going to be in specific parts of the building, the facility department opted to do an entire BIM model for the entire facility, both interior, exterior, MEP, and structure. So it was a very, very sizable project. And then besides the LOD 300 BIM deliverable in Revit 2014, we also would publish web shares as well. So not only was the sheer size of scanning a 17,500 sheet arena going to be a challenge, this project posed significantly others as well. Since MEP existing conditions was critical, as we all know, MEP isn't exposed and out in the open. It's located up in difficult to reach areas, above ceiling, and even in this facility even had a large roof plenum, which I'll show here in a little bit, which contained duct, HVAC, and entire MEP systems. Since this project was going to be phased, due to a very tight design timeline, we had to, and of course for all our projects we do this, but for this one, a survey control network being so having that there was going to be paramount for the success of this project. Secondly, since the scanning was going to take place over a extended period of time, protection and maintenance of both our survey control and scanner reference targets in an active facility, we utilized various ways to do that, which I'll explain in a little bit. And then lastly, we did this in the spring. College was still in session, so there's a lot of activities going on in a building like this, including graduation. We were dealing with summer basketball youth camps, so it was scheduling around the facility activities was pretty important for this one. And if we didn't do that carefully or work closely with the facilities department, we would have lost some critical field data collection time meeting our clients' timeline. So to tackle a project of this size, under these tight timelines, we approached this job with using a 3-person crew. We utilized 2 laser scanners, both with 2 competent 3D scanning technicians with a lot of experience. We utilized a long-range X330 on the exterior. Then we utilized our Focus MS-120 to do the interior. And then the X330, we also use that in short-range mode inside as well. In all, it took about 4 weeks to do all the field data collection, and then our staff licensed surveyor did the surveying around the entire facility. We ran a traverse around the exterior and then all the way through the interior and wrapped around the corridors, so that which would serve as the basis for verifying our scan registration. And then we also use that to georeference the point cloud to state plane grid and datum using GPS and total stations to do that. We also did a sizable amount of this project in color. So we ran color overlays with a lot of the scanning as well, which for a project like this we thought was a nice touch, but it did add some considerable time to the field operations for this job. So as I mentioned earlier, the critical MEP systems and ducts outside of the 3 mechanical rooms, which were easy here, really the difficulty lied with getting access and clean line of sight to all the MEP that was contained within tucked under the seat risers, and then adjacent to the corridors were small, long areas that contained a lot of ducts and air handlers. So not only was scanning that hard, tying all that back into control, scanning down a long corridor is always really tricky. So we had to ensure that we were entering these, coming off of good robust control, and then closing back in control just to ensure that we didn't have any twisting or misalignment in our point clouds. So that took a lot of effort just to scan those. Furthermore, up in the underneath the roof in this facility, where the just above the scoreboard was a lot of MEP was contained up there, as well as a lot of structure. Again, they are going to be upgrading the scoreboard here, so we needed to carefully scan all the systems above up there. A lot of that was done off narrow catwalks, again with limited line of sights. So really, it was. I know Chris made a comment earlier, which I completely concur with. We took probably more scans than we needed to, but with limited line of sight, it was really, really paramount that we did that because we couldn't get up close and personal with a lot of this stuff. We had to scan it from a distance. So that was how we did this. So in all, we were just a little over 500 scans to complete the laser scanning field data collection for a job like this. And then lastly, we in the corridors, ducts and MEP were contained above laying ceiling tiles. So thankfully, we could remove multiple tiles, and there was some exposures to the side. So we did have a pretty decent line of sights up there, and using similar field processing. We used elevated tripods, ran the scanners remotely with a Kindle type device, so that we could run the scanners 10, 12 feet up in the air. So again, we had to phase this job. So we were, sending crews to the field, and then data was coming back. So back in the office, once we had the survey reduced and balanced and checked, then we were starting in the office. We would start our registration process. We were using ferrocene. We did target this job. We're still strong believers in field targeting. To help protect our targets, we utilize reference stickers with unique numbers so that we can reproduce sphere targets if we need to. In the event we lose something or we need to check something, or if we're closing back on control that on beginning or ending points of scan chains. So for us, we believe that's really still a pretty robust process. So we're strong believers in that. And then since we do targeting, Faro has a really slick auto target recognition feature. So we do a lot of that post-processing overnight, which acquires all the targets, and then a technician can spend his time registering and then checking that and verifying the alignment against the survey control. So that product really only took us 50 hours of time, which we think is pretty quick for a job of this size and complexity. Once our staff surveyor verified and checked off on the registration, then we began the process of creating the recaps, which we would use later on during the modeling process. And then we also publish web share images. We host them here. We have a dedicated server. We host the web share images, which we would use. Our modeling staff would use that to assist in the modeling, and we also made that available to project stakeholders and the design firms as well. So in all, staff of 5 worked on the post-processing in this job. So once we got through this, we then were ready to begin the modeling. The way we approached the modeling was we broke it down into disciplines: MEP, architecture, and structure. And we also broke those down further into areas of the building. Again, we were phasing this job, so we only had access to certain parts of the building, which really, in the end, I think is a better way to approach large projects. Do them in small pieces. You can really push Revit, even though with recap it works a lot better, but even putting a lot of point cloud cloud. Despite having really new and modern computers, it still stresses it pretty well. So we break the job into pieces. We can do that. Everything's georeferenced and coordinated. So it's really the best way to work it. So using Edgewise MEP with the new Duct tool, one of our specialists then took on the task of doing the MEP modeling. So we set a lot of those up, those post processing overnight to run all the extractions for the pipes, and then using the ducting tool, where our old workflow was a lot more cumbersome to use, as referenced earlier by Chris. And again, you're modeling in 2D and section views and going back and forth. You know, once you're using the Edgewise tool, now you're modeling in 3D, so you're modeling right in the context of the point cloud itself. You're QCing as you go, and then the transitions and runs are much easier and significantly faster as you're building those up right in the context of the point cloud. Having the lookup tables placed in the nominal size ducts. A lot of times you might only had a couple faces of the duct picked up in the scan due to line of sight limitations. So using the reference drawings, you could at least look up what the intended size was, and then do some verification later in the field. So that really gave us a lot higher confidence in the duct placement and position, and you know, it truly saved us a significant amount of time, roughly about 50%. We found using the duct tool for this job. And you can kind of see here how up in the corridors and some of the mechanical rooms where we had quite a large amount of it. So the finished model of this size under an aggressive timeline really required a lot of careful planning and execution, both from the field and in the modeling process. So for us, using feature extraction tools to begin the model with some elements already modeled in Revit, along with that point cloud, really is we don't believe there's any faster, more efficient, cost-effective way to do it. Having all that right up front. And then furthermore, we using the Smart Sheet feature, again, both for the ducts and the pipes, it really acts as a really effective tool. What we're doing is we're kind of QCing as the MEP as we build the model. So it's really a nice process for doing that, for doing a model of this size and magnitude. And you know, lastly, since it was phased, and since we were able to really meet those tight deadlines, this is a really successful project for us. So in closing, you know, Chris mentioned this as well. Pre-planning, having a staff in place, communication and scheduling. I think that goes without saying. That's, you know, really one of the keys to success for taking on a project like this, both from the field and modeling perspective. Verifying your scan registration with survey is paramount. You know, especially when you're chunking up a job due to customer request to phase the job. Any twist or misalignment, you're now put forth a lot of effort modeling Revit families that are in the wrong position, and we all know that's not easy to undo that. You're essentially starting back over. So you know, having that robust QC process is really going to save you a lot as you proceed forward. And again, we think we're finding with the Edgewise tool, we can perform continuous QC checks both in the model as we go along. It's always important to, we believe, although we're laser scanning and we're not relying on them a whole lot, we still like to get our hands on the record drawings for at least to verify nominal pipe and duct sizes. We believe that's a helpful tool in doing that. Lastly, ask your client, do they want the point cloud georeference to state plane or even an existing model? Try to ask the questions of how you're going to be using this later on down the road. We believe that's a something that you should offer to your customers. And then I put it last year, but I really think this is probably the most important. Chris even touched on it a little bit. Try to define before you start a job like this what your model, what your LOD is going to be. Really, a lot of customers are just still requesting BIM deliverables created from point clouds. So we're utilizing the BIM forum LOD spec for a lot of our projects. And then we're also not only members of the US IBD, which is the U.S. Institute of Building Documentation, they're also providing some similar guidelines for LOD specifications as well. And we believe it's really going to help smooth the communication between a service provider and a customer and end user so that they have an idea of what they're going to get in their final deliverable, because the laser scanner gets everything and all that doesn't get translated to the BIM model. So having that is quite important. And with that, I'm going to wrap it up, and thank you for taking the time to listen.
Okay, great, Mark. Hey, that was really interesting, and I think probably the most interesting fact was that Indiana University even let a Purdue grad like yourself in the front door to do this project, huh?
Well, I have to correct you there, Kevin. I'm actually not a Purdue grad.
Oh, no, okay. All right, sorry about that.
It's okay.
Well, let me have. There's a quick question for you, Mark, and that was somebody wanted to know what were the size and shape of the targets you used. We are using 6-inch diameter round spheres. They're known as the flexi spheres. We use those mounted on bipods when they're setting up over survey control. And then we also utilize them with reference stickers to place on magnetic surfaces. We're not using a lot of paper targets anymore. Mainly using sphere targets. Okay. All right. Great. All right. Terrific, Mark. Appreciate that, and we'll have you back on in a few minutes for more questions. And right now, we are going to have a demo. And I'm going to hand it over to Kevin Williams and ask him to show us what's new in the October release of the Edgewise BIM suite. Kevin, take it away.
Thank you. Thank you very much, Kevin. Are we still viewing your screen? I'd like to go back to that slide real quick, and I don't have that on my machine.
Okay, I'm sorry. Which one do you want to? The slide that has demo on it?
One you were just on. Yes.
Oh, okay. Yeah. All right. I'm going to go presenter back to me then. There we go.
Okay. Thank you. Sorry about that.
That's right.
So yeah, thanks a ton for the intro. We've got a brand new release coming out at the end of the month here. We're all really excited about, and the beta is going to be available today. It's officially available today. After this webinar, we're going to be sending out a download link to all of our existing MEP BIM and MEP customers to try out the new beta. And it's got some really cool new functionality. It's got a number of smaller upgrades, but the two biggies are, obviously, we've been talking about the square and rectangular duct extraction. The other is what we're calling Clearview, which is a brand new updated version of the ability to be able to look from the point of view of the scanner. We've cleaned up the visualization there a lot. It looks really clean and sharp, and you can jump seamlessly between 3D view and the clear view, and I'll show that first. So let me take control back. If you can give that to me again, there, Kevin. Sorry about that.
Yeah, that's okay. Yep, and you should have it now.
Perfect. Thank you. Okay. So here we are looking at a full 3D point cloud of the guts of some chemical processing plant, and this is our standard visualization engine. but we've improved the ability to look from the point of view of a scanner. And so if I double click on one of these spheres, it's going to zoom me into that sphere and refresh the view, and it now looks like a photograph. But I'm still actually looking at the points. You can see a little in the little bit of lag. You can see that we're actually still looking at the points, but it's cleaned up a lot since the last version of the software. I can zoom in, and it continues to just look like I've zoomed into a picture. So it now gives me a lot clearer view that I can work with. I can jump from scanner location to scanner location. So here's another scanner location I'm going to jump to, and we can keep navigating around. And I can easily get out of this mode, but I can also work within this mode. So here's an I-beam up here, so I can easily use my steel extraction tool to capture that I-beam, and now I can jump to it in full 3D view and look and see what I've extracted there. So that's the new clear view mode, and showing you how to jump in and out of that. I think that's going to open up a lot of cool new workflows, make the whole modeling process go a little more smoothly. Let me show you the ducting next. So this is the part that I'm probably most excited about. We've had people asking us to build square and rectangular ducting tools for some time now, ever since we started working in the MEP arena. And over the summer, we worked with a handful of really knowledgeable Revit HVAC modeling guys, just super talented people who are familiar with the workflows that are available now and the pain points that are out there. And working with those guys, we came up with what I think are some great new approaches to modeling these square and rectangular ducts. When we first started out, we went around collecting. We got as much data as we could, and of course we wanted to model the most the most difficult thing that we could possibly find. So we looked all around, scoured all of our customer data sets, asked for more. Turned out the craziest piece of ducting we could find was sitting in the basement of one of our application engineers. So he took home one of those little dot product scanners and scanned this thing in, and you can see it. Let me zoom out just a little bit. There's one straight piece of ducting in this entire little run here. As far as ducting goes, this is a real piece of art. And in fact, it was autographed by the guy who built it. So it's kind of an interesting little story there. But there's a straight piece of duct right here as it connects to the blower box, and from there on out, there's a little. This isn't even a Revit item that can be brought into Revit. It's some kind of a round transition, which we'll model it as something that can be read into Revit. Then goes into this S transition, which I'll model as two elbows to get it into Revit. There's a strange homemade transition up here, and then if I rotate it here, you can see that even this upper part that kind of looks like it ought to be straight is not. It's yet another transition. So what I'm going to do to model this, let me just kind of walk through the workflow, and then I'll do it in this new set of tools. I'm going to model it. The extraction tool extract straight pieces of duct, and then we've got some very easy to use connection tools that will connect it all up. So I'm going to go through. I'm going to model this one lower piece as a piece of straight duct. Then we've got a combination elbow / transition tool that adds them in combination with each other. So I'm going to skip over this transition and an elbow, and I'm going to model this straight section that forms the boundary between these two elbows in this S. And then I've got another elbow and a transition, and I'll model another piece of straight section here at the top of this transition. And then finally I'll build, even though I don't have data, I'm going to show you how to build a final piece of straight duct at the top using the copy and paste tool, which I obviously didn't show Chris and Jerry the tool before they got the alpha, and I apologize, guys, because you were saying you couldn't find a copy paste tool. There is one. So let me go ahead and model this duct and show you how the new tools work. So just like our steel extraction tools, I'm just going to draw a defining box around the straight piece of duct here. It ignores the little pipe in front of it. So there's my first piece of duct, and I've got little extension tools that I can modify it with. Then next I'm going to try to get this piece of straight duct between the two elbows. There's a piece of insulated pipe in front of it, so I'm going to cheat a little bit so I can get a better view of it and look at it from the back side here. And use the extraction tool. All right, and that got a little piece of duct that fits there in the middle. And then I need another piece of duct up here. All right, and you can see this didn't, I'd actually like this to line up vertically. So I want it to be parallel to the bottom guy. So I'm going to, let me turn off the point cloud, and I'm going to use my snapping tool to make it parallel to this bottom one. Then I'm going to grab both of these guys and do an alignment real quick. So when I do start making the elbows, they're going to line up with each other. So I'm going to use the align tool, and this just slightly rotates everything so that they fall in a nice clean line with the bottom one. All right. The last thing I'm going to do is I'm going to use the copy paste tool to copy this upper piece of duct. And whoop, there we go. And I'm going to drag him up a little bit and make him, let's see, collinear with this piece. I'm going to drag him down so I can start seeing the point cloud. Now I'm going to open up the smart sheet and recalculate the points around him. Now this is the primary QC tool, and if you guys have used the structure modeling tools in Edgewise, you'll recognize this. Works the very same way as our structure modeling tools. So I'm going to use the resize tool and resize it so it stays out of the points on this transitional piece of steel. All right. Now I'm going to close the smart sheet and turn off the point cloud, and I'll show you how I'm going to connect these guys up. All right, so I'm going to grab these top two. They're connected. If we look at the point cloud, there's a transition between them. So I'm just going to click the transition, and that makes our transition there. Then I'm going to select these next two guys, and there's a transition and a radius elbow between them. So I'm going to add a combination there. And then same thing with this bottom pair. I'm going to add a radius elbow with the transition. All right, so there's my basic shape. Now it doesn't quite, if I turn on the point cloud, it doesn't quite fit the data yet. But we've built a set of tools to quickly go through and change the shape of these. And when I rotate it, it'll come back into shape. Change the shape so it matches up with the shapes that I've actually got here. All right, this guy is off quite a bit, so I'm going to use my little dragger here. I need to drag this tool up. There, that looks pretty good. I'm gonna, this is my radius adjusting tool. There we go. And there. And finally, I'm just going to drag this guy down to connect up with the little box. Okay, there we go. So now I've got, if I turn off the point cloud, we've got a very crazy shaped piece of ducting. There's little tiny mismatches at the elbows. So I'm going to grab these guys. There we go. I picked on the wrong guy there. And this guy needs to be aligned there. All right. And now we've got a connected set of ducts or ducting pieces. From here, like all of our components these days, we can export this directly to Revit. So let me go ahead and do that. And show you what it looks like inside of Revit. Well, that's not supposed to happen. Let me re-export this guy. Actually, I might see a problem. I'm going to delete this bottom one and the top one. I broke the connection. Still not coming in. Sorry guys, this is a beta. So let me try a new. I might have messed up my template. I've got something messed up with my DLLs on this computer. So I apologize for that. But it should come in as a fully intelligent Revit object. But I got a brand new computer yesterday, and the DLLs are giving me a little bit of a headache. So I apologize. I'm not able to show that right now. But it does work and will work just fine on the beta version. It's a matter of just installing it properly. So let me hand this back to Kevin Corbley.
Okay, sounds good. And you know what? We're going to just go ahead and we are going to jump right into the Q&A. So I'm going to ask everybody to turn their mics back on, and let's take a look at some of these. Let's see what some of these questions are. Kevin, we had several for you just come up. How does Edgewise handle HVAC systems with insulation and runs with breaks in the insulation?
All right. So the resizing tool in the 2D Smartsheet view allows you to go back through and look at the data and refit the data based on what you know about the installation. So the initial extraction is going to be based off of the planes that it finds on the outside, because it obviously can't see through metal walls. But you can resize and refit that based on your knowledge as someone who's actually been to the field and seen these ducts, and you know what's actually supposed to be there. You can recenter them inside of that and build the ducts as they really should be, really quite easily. So it's a matter of using those resize tools in the 2D Smartsheet view to be able to do that.
Okay, yeah, and this question came in, Kevin, kind of early in the presentation, so I don't think you answered it, though. Do you expect future ability in Edgewise to detect and model flex ducts?
Future ones, yes. That's going to be version 2 of this technology. We got the core capability to go through and model all of the strange transitions and elbows and things like that in this cut 1 of the software. But and talking to the guys we work with on the experts who are out modeling this on a daily basis, they said that wasn't as key, so they didn't want to hold up the release of this software for that capability, but it's something they want to see in the next version. So yes, it will be coming, but it's not available just yet.
Okay, and next question is for Chris Heliotis. How much modeling time was there for each modeler in Edgewise?
Oh, well, I'd have to go back and really dig in, but I would say probably a total of a week and a half a piece. There was more piping than ducting, so the piping took the majority of the time. But yeah, I would say a week and a half to 2 weeks each.
Okay, great. And Mark, here's one for you, but I'm going to let Chris chime in as well. But Mark, you go first on this one. Really interesting. What process are you using to verify point cloud alignment with survey control? And is this process communicated through the Revit model?
Great question. We're verifying point cloud alignments in our point cloud registration software. So for this project that was seen, what we're doing is we're bringing in the external reference coordinates, and we're then comparing that fit to the sphere fit in the point cloud, and then just doing a verification on what the error is. We're not doing any of that in Revit. So that's all taking place before any of the point clouds are converted to recap.
Okay. Chris, do you have anything to add on that one?
Yeah, it kind of depends on what the end result. Obviously, I'm not doing targetless registration on everything, only in applicable situations. If I am doing it targetlessly, generally what I'll do is I'll collect a set of verification points with a total station, and once I've done the targetless registration within Recap, I'll bring it into a program like Cyclone, and I will QC against the tide information.
Okay. All right. Good. And Kevin, here's an interesting question. I'm sorry. Did somebody want to jump in?
Yeah, Kevin, this is Kevin Williams. Hey,
Yeah.
can you switch me back to presenter? I
Sure.
think I'd lost my license to Revit in the interim as I was waiting, so that
Okay.
but I got it to work. And I think it's important to be able to show real quick what it looks like coming into Revit.
There you go. All right. You
Okay,
should be
thank
presenter now. Yep.
Okay. So we give this little report that shows what's coming into Revit, and so you can see whether or not all of the objects are going to come in properly first. And then let me jump to this piece of ducting that we created, and you can see if I tab select, everything's connected. if I look at an individual piece, it's everything functions like it should. So it's connected. You can immediately jump into doing airflow analysis or whatever you are going to do with this Revit model. So that's a critical component. It does come in as intelligent information once you create it there in Edgewise. So I'm sorry, Kevin. I interrupted your question, but I thought this was important to the show.
Oh yeah, no problem at all. Great. Yeah, the question was, it was kind of an interesting question. It sounded like somebody who's already using Edgewise. They said they were having trouble getting the here it said, when exporting pipes from Edgewise to Revit, elbows don't show up. How can we solve this issue?
Yeah, that's a very common problem. The problem is that Revit likes the elbows to be very close to 90 degrees. If they're off by more than a degree, they're going to not show up. And so there are two solutions to that. One, you can manually go in and tweak each of the elbows because Edgewise captures reality, and when pipes get bent a little bit, they're not going to be 90 degrees anymore. And so Edgewise is capturing what's really there, but Revit balks. So to fix that, there is a tool in Edgewise that snaps the pipes to be perfectly orthogonal or parallel. And you can use that with an error tolerance to go through, snap everything before you export to Revit. And then you can also go into the smart sheet and the things that fell outside of your tolerance, because you don't want to be snapping everything to perfectly 90. So the things that don't fall within your tolerance, you can go back through and see where your problem areas are, and then manually fix any of those. So send our service department an email, and we can walk you through that really easily and make sure that everything comes through like it's supposed to into Revit.
Okay, terrific. And Mark, here's a question for you. Were large coordinates an issue for geo-referencing to state plane coordinates? And when in the workflow did you reference to state plane?
That's a fantastic question, and the answer is yes. Large coordinates are an issue for Scene. They're an issue for Revit. So what we were doing is truncating those. And again, we're doing that process in Scene prior to bringing anything into Revit. And then that's how we've been overcoming that.
Okay. All right, great. And let's see, we've got time for just a few more questions. I realize we're running over. But Kevin, here's another one for you. Is the modeling fitting to parts tables? Yes,
there is a part table for the straights that it is using. So with ducting is a little bit interesting. People usually there's no real standard ducting out there, or at least there's a lot of non-standard ducting out there. So it rounds it to nominal half inches in the United States and centimeters outside of the United States. Particularly the transitions in the elbows try to fit to a standard, but they're fully adjustable. Same with the transitions, and all of that will come across properly into Revit.
Okay, and
we can also export to AutoCAD.
Great. Okay, and Chris, do you have an estimate of the number of HVAC and piping elements created in the final Revit model of the project you showed us?
No, I'm not prepared with that number. Well, see, we had about 300 scans. I'm going to throw out a number on the order of 1,500, 2,000. I mean,
wow.
I really don't know. I'd have to go back and do a query on that. But it was a lot of pieces. We were modeling down to generally 3/4 to 1 inch conduit. Unfortunately, I can't show all that data in this particular situation. But yeah, if you want to count individual pieces that were extracted, it was well over 1,000.
Okay, all right, great. And Kevin Williams, which rendering or visualization technology did you use to create the new visualization engine?
I'm not real sure how to interpret that question.
Okay, well, let me kind of short. You want to take us?
Yeah, go ahead.
I was going to say short on time.
Yeah, skip over
Yeah.
that.
Yeah. Is there this also for you, Kevin? Is there a specific Revit content required to be present for piping and HVAC in order to coordinate with Edgewise?
Yes, that's a very important point. I'm glad somebody asked that question. It's you do have to have Revit MEP in order to work with this. So the full building design suite includes that. The full Revit version includes that. But if you only have, say, Edgewise Structure or Edgewise Architectural, it will not come in. It requires a systems template to load this.
Okay. And we've got time for just one last question. Looks like it's going to go to you also, Kevin. What duct type, transition type, elbow type does Edgewise bring into Revit? Can this be defined by the user?
It brings in, and I'm reading off of what Revit is calling it. It's called, so I'm clicking on my screen, it's a rectangular transition length standard. And from there you can change it to whatever else. It plays like a regular Revit family and can be converted to whatever. That's the transitions. Let me give you real quick the elbow. Rectangular elbow radius is what it's called in Revit. If that helps.
Okay, great. Anything else on that one?
No, I think that's it. They can
right.
They're fully functional Revit families. They can, and once they're inside of Revit, they can be converted to another type if you so desire.
Terrific, and that's the last word then. We're out of time, and quickly like to thank everyone on the panel, Mark Hanna, Chris Heliotis, and Jerry, who helped also from Westlake, and Kevin Williams, of course. And I'd like to thank everyone in our audience. And on behalf of our panelists and our sponsors, Workflow 4.0 and ClearEdge 3D, let me thank everyone for joining us today. And a reminder, you'll be receiving an email after the broadcast with a link to the recording. There'll also be a chance to subscribe to the newsletter and other follow-up information. And we hope to see you again for our next webinar. Thanks for joining us.